So you want to disable FireWire if you can. Epoxy is a good solution. You want to disable your PCMCI port. Epoxy, again, is a good solution. And you want to disable hibernation. You never ever want your computer to hibernate, because even if you remove your cryptographic key from memory, there's a lot of other interesting stuff in computer memory that we could access. The keyboard buffer, for instance. When you entered your password or passphrase, there's a keyboard buffer in there, and that keyboard buffer is somewhere in memory. There's also all of your other passwords. There's the page cache. When you access a file on your encrypted file system, Linux will by default copy that into a buffer called the page cache. So your files that you access on your encrypted file system will be copied in clear text into memory, and that memory will remain intact until it's needed again. And so even if you unmount your crypto partition and then just shut down, it won't need that memory again, and it will remain in memory. And especially if you go into hibernation, all of these files will remain. And this guy at IBM actually did file recovery from the Microsoft EFS encryption scheme using files from the page cache, or data from the page cache, to recover files. You want to disable Control-Alt-Delete or any other way to reboot your computer. And you never ever want to do encryption in virtual machines. That's just plain stupid. I know that, for instance, Xen and virtual PC or virtual server, whatever it's called for the Microsoft platform, has this wonderful option to save the state of your machine when it's rebooting. So if you reboot it, it will write all of your memory to disk so that it can continue when you boot it back up again. And this sounds really nice, unless you have cryptographic keys in that memory that will be written to disk in clear text. You might want to have a BIOS power on password, so that if someone actually is able to get physical access and reboot your password, reboot your machine, it will ask for the password. We tried this on this machine here, and for one reason or another, it only asks for password at cold boot. So it's not really that useful, but it feels better anyway. And you want the auto-locking screensaver. You really want your computer to go into to lock the console when you leave it. And there's a whole debate going on how long you should wait before you enable the screensaver, but the main thing is that you want to enable the screensaver. So, I think that was it.
You didn't cover a previous program that you refer, like TrueCrypt or BestCrypt or things like that, but this is only for lack of time?
Actually, I decided to begin with I wanted to look at TrueCrypt and DMCrypt, but since CryptoLoop and DMCrypt is default in the Linux kernel, I decided to look at them. But BestCrypt and TrueCrypt has the same problem. It needs to store the cryptographic keys in memory, and wherever the memory goes, so does the key.
Could you maybe go into a bit more detail on how this PCMCIA FireWire thing works? Or where would you actually put the memory? Where's this?
Okay, so the FireWire actually has this really nice feature that it allows you to do DMA access over FireWire. So if I plug these two computers together by FireWire, this computer can read the entire memory of this computer using DMA. So direct memory access from hardware. But if this computer doesn't actually have a FireWire port, I need to introduce the FireWire port, and an easy way to do that is by the PCMCI card. So I plug the PCMCI card in, it loads the drivers, and suddenly I can interface these two computers and read the entire memory to this machine. So I have to have the correct software on my computer to be able to do this. But this software is available since many years because people have been researching doing FireWire memory dumps for quite a number of years now. The only problem is that some machines doesn't have FireWire, and this card solved that problem.
I think I'm the guy, either me or Ralph was the fellow talking about the Hibernate image on macOS 10 at the Congress last year. So I did some more reversing on that, and it turns out that it doesn't actually encrypt the sleep image. I've never found one in the wild. I've inspected over 200 Macs legitimately and have found that none of them have an encrypted Hibernate image, and by default, anytime you put an x86 macOS 10 machine to sleep, if it's a laptop, it'll write out var VM sleep image, and it's unencrypted. On the offhand chance that you did happen to find one that was encrypted, though, it's either stored in some, like in the EFI or the open firmware memory or the disk CMOS backup stuff. And so all you have to do is ensure that when you boot the machine, you don't hit the mock kernel entry point, and it won't free those variables. So if you boot off, say, Refit, the EFI shell utility, you can dump NVRAM without having to worry about it, and you can actually extract the sleep image and do all that stuff as well. But inside the Hibernate image, you have encrypted swap keys. So have you done any research about recovering encrypted swap files? Because
no, actually I haven't. This is basically what I've done. I wanted to see if it was possible to like recover the keys and how difficult it would be to reuse them. So it's the reusing step that I've been researching. And it turns out that reusing the keys is actually quite simple once you know how to do it. And as I said before, if I had more time, I could research other cryptographic systems as well. For instance, FileVault for Mac OS X. But
don't bother researching FileVault. It's not interesting.
I mean, all of them have the same problem. They store the crypto keys in memory, and wherever the memory goes into hibernation files, you lose it via DMA or anything, your crypto keys are gone as well.
Maybe a follow-up question on this one. When you store your hibernation file in an encrypted swap image, is it secure?
I believe the question was, what if you store your hibernation file in an encrypted swap image?
Yeah.
Yes. The problem is, when you return from sleep, or when you boot again, you need the key to be able to boot up again. And for instance, Mac OS X or Windows, they simply have no simple way to input the correct key. I know that Suspend 2 for Linux actually has the capability of doing this. You can boot into an init.rd and input your key, and it will be able to decrypt the hibernation image and launch into that hibernation image. So yes, that is absolutely possible.
Okay.
Yes, once you're running again and you have your key in memory, I can recover it using, for instance, the FireWire card.
A friend of mine told me that there is a possibility.
I'm terribly sorry, I can't hear you.
Okay, they're having fun. A friend of mine told me that the Linux kernel has the possibility to disable the FireWire feature that makes the DMA transfer possible. Is that right?
Yes. The question was, can you disable the FireWire feature? And yes, a normal computer or a normal Linux installation, with or without FireWire, will allow you to do DMA. But there is an option for your DMA, for the FireWire to disable DMA. And if you use GRSec, for instance, it will have this disabled by default. So yes, it is perfectly possible to disable it by the driver, so that when I insert this card, nothing will happen. On the other hand, if you're actually using FireWire, it will be painfully slow without DMA.
To my knowledge, the Linux kernel changed the default, and all recent kernel have a so-called war driver for the FireWire. And unless you load that, the kernel is fine. Only if you load the war driver or enable that war mode, the DMA hacks work. And I think the older kernels have the default wrong, but all recent kernels should be fine, to my knowledge.
I haven't researched that actually.
Yeah.
What I did was I tried it and it worked. So the interesting part is that you will actually have to take measures yourself, or the kernel developers have to take measures in order to secure this. By default, most operating systems and by default most users are vulnerable to this problem.
And about the hibernation to a encrypted partition, it also works fine with the stock software suspend. You can simply boot a normal, from an unencrypted boot partition, a normal kernel with an init rumfs, and that can then set up an encrypted root and an encrypted swap partition, which you can also use to resume from an hibernated kernel, so that works fine.
Yes, Linux has the software suspend feature. That means that Linux is doing the hibernation stuff. But on the other hand, a lot of laptops has the hibernation feature built into the BIOS. And so if you enable this, it will actually do suspend of your Linux laptop whether or not you like it, because the BIOS thinks, oh, I'm running out of battery, let's save everything. So if you have this feature enabled in your BIOS, it will do hibernation whether or not you like it.
If you want to use hibernation together with encryption, would it be the best thing to put it on an LVM volume?
I didn't hear the question.
Wouldn't it be the best thing to have an LVM volume and then store the whole system in that LVM volume together with a swap partition?
If it would be the best thing to have the whole file system and the swap partition in the crypto file system?
Yes.
Yes, of course. What you want to do is you want to encrypt everything that you can get your hands over and encrypt. Because when they come and get you, they can use all of the little pieces that they find to like try to sort out together what your password for the encryption is, for instance. So let's say you have a root file system that is unencrypted, and then you have your secret data volume. They're going to brute force your passwords from your password file and try to use them in the hopes that you have used similar passwords. Or for instance, just an easy thing. Let's say I brute force your password from your password file, and then I discover that the word you selected for your root password is a word in German, or perhaps a word in Spanish. Then I can use a Spanish word list to attack your encrypted file system, because I can make an educated guess that it would be something similar. So encrypt everything.
Okay. You mentioned that you can find remainings of files in the file system cache after you unmounted the cryptical volume with crypto setup. Have you actually verified this? Because I guess that the Linux cache is a block file system cache, a block device cache, and should cache the encrypted pages of the block device and not the unencrypted pages of my files?
It depends on the cryptographic system that you're using. The guy who actually researched this did it on Windows, and he wanted to recover files from the EFS file system. But if you look at the block layer of Linux, it is highly likely that it has one encrypted page cache and one unencrypted page cache, but I'm not really sure of this. On the other hand, there will definitely be a queue where there comes an unencrypted block into the queue, and then it is supposed to write this. And since DMCrypt and LOcrypt are running in a pseudo user space, kind of like a kernel thread, there will definitely be a queue for these that is in memory. So even if the block layer doesn't actually, page cache doesn't actually store it, there will definitely be a time when it is written to unencrypted kernel memory. And if we are unlucky, that page isn't used again, and then it will remain there for inevitable time.
There actually is another method of obtaining memory dumps. Some remote management cards like Hewlett Packard's ILO, the integrated lights out management cards, are said to be able to dump memory. Have you done research on that?
The question was, have I done any research on other types of remote memory imaging techniques, for instance, the Compaq ILO or the Dell DRAC or whatever it's called? No, I haven't. My research went mainly into how do I reuse the keys once I find them, and then I went to like researching a bit what kind of ways do we have to make a copy of the memory. And of course, any type of hardware that interacts in that way, such as the ILO, or rather, as soon as you have a PCI card that you can somehow manage, it's highly likely that you will be able to recover memory, because PCI cards has DMA access. And as soon as you have DMA access, you can access all of the memory and you can read it out, everything. On the other hand, there are machines coming out now that has something they call IO MMU, IO Memory Management Unit.